Hello and welcome to 2016 question B2. This was an intersecting planes question. So the image on the right shows a restaurant which consists of a series of intersecting triangular glass surfaces, or planes. In figure B1 we've got our plan and elevation of these planes, and then the data related to the horizontal and vertical coordinates are here on the right. So what they want us to do first of all is they want us to draw the plan for the four triangular planes and complete the elevation of the intersection of the planes. ABC, ABD, DB, or DEB. So to start, they're saying nothing about plane F. And if we go here and look at our coordinates, we have the coordinates for A, B, C, D, and E, but F, there's this little question mark, so that's obviously going to be a problem that we have to solve later in the question. So for now we'll just ignore F, and we won't draw in that plane. So we're going to locate those planes. So our coordinates are out the way, up and down. So using those, I'll draw my XY line here. So 130 to A, 160 to B, 100 to C, 180 to D, and 210 to E. And just for the sake of this, I'll locate where F will be. Just put that little mark. I'll save a bit of time later. Now I'll do my vertical measurement. So from A, up 40, down 80. So up 40 there to A, and down 80. B, 85, 35, up 85, down 35. C is also up 85. C and down 35 also. D is 30, 75, 30 there, and 75. E, 70, 25. 70, 25. And I won't draw in my F, but I'll just locate where it's going to be, so 55 down. And let's draw our planes then. So we've got ABC, A, B, C, E, D, F we don't have yet, C, A, B, D, E, and F is just there, which we're not going to use yet. Elevation. ABC and plan. And as I said, I could draw in my last plane, but I'll just leave it till the end just to avoid confusion. So that is the first part done. Quite simple, easy marks there to pick up. Part B, they want us then to determine the dihedral angle between planes ABC and ABD. Okay, so ABC, it's ABC, and ABD. So we first of all want to identify the line of intersection between them. So our line of intersection there is AB, is our line of intersection. So what we want to do is we want to find our true shape, our true length of that line, and then look along that true length line. So we're going to take an auxiliary first of all, looking out perpendicular to line AB. That will give us the true length of it, and then we'll look down along it using our second auxiliary. So sliding set squares. Project out A, B, C, and D. And I'm creating an auxiliary elevation over here, so this is going to be heights taken from the elevation. So let's start with A, height of A here, which I could also, I suppose, take from our coordinates. So A down up to B and C actually are at the same height. They're at the same height, just to show that. So we'll go to B. C, and finally the height of D. So I can draw my line. This is my true length line AB. What I was trying to find. So here goes A, B, this is C, this is D. We're also drawing the rest of the plane ABC. Okay, so this is my true length line AB. So I'm going to look down along it, okay, down along it there, and see it as a point Q. So second auxiliary taken. So just project these first of all. XY line then at 90 degrees to that. Sorry. XY line there, or X2, Y2. Okay, so second auxiliary, I'm projecting from an elevation, an auxiliary elevation to create an auxiliary plan. So we'll go back to our plan view. So two views back, 1, 2. So from my X1, Y1 back there to this view. So my distance for AB, we can see here, should be the same. Just to prove it, let's start with it. AB, that distance and that distance are the same. So when I project down, I'll find the point view here of AB. Okay, that's AB on top of each other. So I know I've taken my distances from the correct position. I get the distance for C. And my distance for D. Distance for D. If I extend this up, okay, so A, B, C, and D. Okay, so as I said, that's a point view of the line AB. So that is giving me the dihedral angle here of the plane. Okay, so I'm going to measure that up. In the question they said to determine it, so we need to just show that now. I got that at 167, so 167 degrees. Okay, so that's the dihedral found there, part B. Okay, part C, draw the elevation and plan of a horizontal line on the surface DEB. So on the surface DEB, so this third surface that we haven't dealt with, I'm going to draw a horizontal line, show it in plan and elevation. And the second part of that question is determine the true inclination of the surface DEB to the horizontal plane. So obviously two of those are linked. I need to do a horizontal line in order to find this true inclination. So we'll start with the horizontal line. I'm actually just going to get a colour out here to indicate that line. So I could draw a horizontal line anywhere on that plane, but we already have a point E that has a reference line, so I'm going to do that. Okay, and then I can find that point where it intersects my, or where it hits my line D or BD. I can find that down here, and that will find my horizontal line there. So there's that horizontal line. I'm going to project that vertically down then onto D, or onto BD. So here's BD, and there we have the plan view of that horizontal line. And what we can say about that is that that line is a true length line because it's horizontal. And we're looking straight down on top of it, so we're looking at it at 90 degrees. So that's a true length of that horizontal line. So they want us to then determine the true inclination of the surface DEB to the horizontal plane. So if I look along this true length line, I will see it as a point view. And I know from my key principles of graphics that if I see a line that's on a plane, if I see that line as a point view, I will see the plane as an edge view. Okay, and if we see it as an edge view, then we'll be able to see where it kind of, or the angle that it creates with the horizontal plane. So we need another auxiliary view looking out along this direction to see that line as a point view. So here's my xy line, or x1, y1. Let's project out all of these points. Okay, it's an auxiliary elevation. We're projecting from plan, so it's creating an auxiliary elevation. So my heights I'm going to take here from my elevation. So let's start with point B. Point B, down and up. There's point B. Point E. Down, and that's the same as the height of that line, so it's going to be a point view of that, and then point D finally. Just extend up point B a bit further. Okay, so we have B, E, and D. And you can see that is one straight line. It's an edge view of that. Okay, so that's an edge view of my plane BDE found. Okay, and if I extend this on, we'll see where the angle it creates, or what measurement of the angle it creates with the horizontal plane, because my x1, y1 is an edge view of the horizontal plane. So let's just extend that on. And they want us to determine the true inclination, so the true angle. So let's measure that. And I get that at 51 degrees. Okay, so that's part C, true inclination between that plane and the horizontal plane. Okay, sorry, and lastly then, the dihedral angle between planes DEB and DEF is 170 degrees. So this is the first time that I've mentioned point F. Okay, so just for the sake of that, I'm just going to draw in my F here, because they're mentioning it as a plane. So there is plane DEF. Okay, and I haven't got it in my elevation. So they're telling us that the dihedral angle between planes DEB and DEF is 170 degrees. Okay, so if I did something similar to what we did over here, finding dihedral angle, they're telling us that that angle will be 170 degrees. Complete projections of surface DEF. So we need to kind of carry on as if we have found that dihedral angle. So we're going to do an auxiliary view and then a second auxiliary view. We'll probably measure that angle of 170 degrees and then see how we can use that then to solve our question. Okay, and really what we're looking for is finding that height. That's really what we're looking for, because then we can apply that to our projection there in elevation. So what we need to do is, this is the line of intersection between those planes. We can forget about the other planes. So this is our line of intersection. We want to look out perpendicular to it, create an auxiliary view to see it as a true length line. Okay, let's see what happens then. Where's my X1, Y1? Okay, and I'm going to take the points that I can take and then I measure. So auxiliary elevation, heights taken from elevation. So let's start with B. B, down. B, point E, point D. Okay, so, and we can't find point F just yet. Okay, which is fine. We have the true length line though, DE, so there's GE, just label them. D and here's B. So that's the important line really in this view. So that's my true length line, and we'll just draw in B while we're here. As I said, we don't have F, but that's not to worry for now. So we'll take our second auxiliary, looking out along this line, because it's a true length line, and that should find us a point view of our line DE, our true length line. Okay, so could use a dihedral or a datum line here. So I'm going to use the datum line just to as a reference line, because that's quite hard to say. Is there a need for it? I've got plenty of space on my page. 140. I've got plenty of space on my page, and this is the last part of it, so I'm not going to bother. I'm just going to use the distances here back from my x1, y1 back to my plan view. So just double check, we should be finding line DE as a point view, so let's just double check that. DE here, that's D to my line, or to my XY, DE to my XY. So that's correct, I can use that. So that's a point view of DE. And then I can also find the point B. So here's point B. Let's do that. So we've got point B, we've got GE, G, comma, E. That's an edge view of them. And we have a point view of GE. So back to our question now. They told us that if we do all of this, we will get an angle of 170 degrees. Okay, so with this as the middle of my two planes, I'm now actually going to measure 170 degrees. So 170 degrees. So that's my dihedral angle, 170 degrees measured. Now, here's the kind of problem solving side of it. Okay, how are we going to find the end of that? Okay, if we think back to everything that we've done before, okay, let's think about how we found the position of these points. Okay, I found the position of DE and B from this view. And if we look here, I've got the distance from my XY to F. So let's get a compass, find that distance. Okay, now I have no reference line here at the minute, but I'm just going to use this one. And we know that it's going to be at that level somewhere. We also know that this is the position of plane DEF. So if I extend that line horizontally over with that same height established, okay, that will find the edge or the location of point F in this view. So let's do that. Slide this over. So that there is point F. Okay, so let's draw on that plane heavy. Okay, now what we're missing is point F in this view and this view. Okay, so let's work backwards now and see can we carry F back. Okay, because if we can project back these, that's in line with where B is in this position. So here we have point F projected back. Okay, and here we've actually found something right here. Here's F projected forward, F projected back. So this is the location of point F in this view. Okay, same way that if you look at point B projected back here, B projected forward, that's where it is. So I can draw in the projection of DEF in this view. Okay, now it's only missing in one more view, and let's think about how we found this view. Okay, we found this view because it's an auxiliary elevation. We took the heights from the elevation, so that height there for E was the same as that distance. So now we're trying to find F back here, so that height should be the same as the height for F. So get that compass, height of F, swing arc, that is the height of F in elevation. So I can draw in point F and plane DEF. Okay, so we've completed the projections there. So that is 2016 question B1, a nice intersecting planes question with a kind of tough bit there at the end, but very doable if you just take your time and use the information they give you.